If there's no other homework questions, what we're looking at today is solving three variable systems of equations. Now, y'all have done two variable systems of equations in Algebra 1, so stuff like 2x plus 3y equals 5 and 4x minus 3y equals 16, something like this here, where we would use substitution. We would get one variable by itself and plug it into the other equation. Or we would get the variables to be the same and add or subtract them together to get one variable to eliminate out completely. So we've done that in Algebra 1. Y'all have done it there. I have a feeling we'll probably come back across it later on. But what we're looking at today is three variable systems of equations. Now this here is going to work very similar to 2, but there's going to be a few more steps to it. So we're going to spend 2 days on this. And it's mainly 2 days going over examples. It's going to be the same process every single time, but I want to spend enough time on it so we can see it a few more times than just 1 day of it and get used to it. Now, there are three different types of solutions we can have. One is exactly 1 point, because in three variable systems of equations, each equation represents a plane, a three-dimensional flat surface. And what we're looking for is where a point or set of points is true for all three equations. So if it's just a point, that means all three planes intersect at exactly one spot, a location. And we're trying to find that x, y, z value right here in the middle where all three cross. Is it has to be true for all three. It's going to intersect at all three if it is true. Now the next one we can have is infinitely many. So the line there, where all three intersect, will be the solution. And we consider this infinitely many. Now we can represent this line by an equation for all three. We're not going to do that in here. We would do it in the pre-calculus class, and we define it by a, because I just pick a value a for one of the variables, and we can represent the other two with equations. And for any given value of a, we can find a solution set x, y, z that would be true. And there's infinitely many of them. And the last set is no solution. Because in any of these three here, well, obviously the three that are parallel to each other do not intersect at all. But the other two do intersect at lines, but at either one of those intersections, it's only two planes that are intersecting, yes? But again, if we want a solution, it has to be true for all three. All three have to intersect for us to have a solution that works. So these two do not, because there's not an intersection at all three. And we'll see one of every type today, and we'll see some more tomorrow. Now, this here are the steps. Now, I did give them to you. Number 1, rewrite the linear systems in 3 variables as a linear system in 2 variables by using substitution or elimination. Step 2, solve the new linear systems for both of its variables. 3, substitute the values found in step 2 into step 1 of the original equation and solve for the remaining variables. When you obtain a false equation, such as 0 equals 1, in any of the steps, the system has no solutions. When you do not obtain a false equation, but obtain an identity, such as 0 equals 0, the system has infinitely many solutions. So we have this here. Now, let's do it a little bit differently. 1. We're going to pick a variable to eliminate. We're going to pick a variable to eliminate. 2. We're going to pick an eliminator E-U-A-T-I-O-N equation. Step 3. Eliminate the chosen variable. Step 4. Repeat steps 1 and 3. And then step 5 is going to be to solve backwards. These are kind of my steps or how I think through it for solving this here. We good to move on? Y'all have these down? Okay. So, the first thing we want to do is pick a variable to eliminate. When I look at them, any of the variables, I'm looking at a variable that I can manipulate easily. So if we look at this here, for x, 2, 4, 6. Well, it's kind of easy to manipulate 2. I can multiply 2 by 2 to get 4x. And I can multiply 2 by 3 to get 6x. That's kind of easy to manipulate, yes? Or if we look at z, 3z, 5z, and 4z, okay, that's a little bit trickier to try to get those to be the same. Because when we talk about elimination, we want the variables to be the same, to have the same number in front of them, so that we can either add or subtract them together and get 0. If we're eliminating something, we want it gone. But what would be the easiest one to choose? It wouldn't be x or z, it'd be y. Now, why would y be the easier one? What values of y do we have? 2y, 3y, and 1y. What's the easiest number to make into any other number? 1. Because 1y, if I multiply by 3, I get 3y. If I multiply it by 2, I get 2y. If I have a variable by itself, I'm going to use it set to be the eliminated first. Because 1 is easiest to work with. I don't have to worry about any other number matching up. I don't have to change any other equation. So if it were me, I would pick y to be the variable I'm going to eliminate first. We're going to have to do elimination more than once. Because how many variables do we have? 3. In geometry and algebra 1, what is the most variables we solve for at one time? Yeah, 1. Because even if we had 2 variables, and we did that in geometry, we never solved for both at the same time. We had to find the value of one to then find the value of the other. Because we can only really solve for one at a time. So even though we have 3 here, we're going to eliminate 1, which would take us from 3 variables to 2. Then we're going to do it, because again, it says repeat steps 1 and 3. Step 3 is to eliminate, so we're going to take it down from 2 to, and then we're going to go backwards to get the rest. So we're going to keep taking it down. So y is the one we're going to take out first. Now we have to pick an eliminator equation, one that we're going to use to get rid of y from the other 2. Well, obviously I'm going to pick the third one because it has 1y. It's going to be the easiest to use. Because since we're getting used to this here, I would denote that equation in some way. That's going to be the eliminator equation. We're going to use it to eliminate y from the other 2. And the reason I do that is because I don't want to accidentally use it to eliminate y from itself. because it wouldn't just do that. It would eliminate everything. Because if we take something away from itself, it's completely gone. Yes? So I denote it, and especially I would suggest kind of be good when you're getting used to this and starting this to denote it so we don't use it again. That's the one we're going to be using. Now, since it is 1y, I don't have to change the other two. Because I can multiply y by 3 to get 3y and y by 2 to get 2y. We're fine. I don't have to change those. So what I'm going to do is I'm going to go on and write them down. 4x plus 2y plus 3z equals 12. And on your paper, make sure to leave kind of some room to either side, because we're going to have some scrap work in the process. Now, if you noticed, I don't have room to either side of my paper, so I'm going to be writing this below those equations and then erasing. So when we do these next few steps, write them to the sides, because we still have more to do underneath this. I just don't have the space for it. If I wasn't recording, I would put it on the whiteboard, but anything I put on the whiteboard won't show up in the video, so there is that too. Okay. So our eliminator equation is 6x minus y plus 4z equals -3. Now, we want to get the y values to be the same. Now, the sign of it, I'm not too concerned with. We're just wanting the numbers in front of them to be the same. So here we have 2y, here I have 1. How can I make 1y be the same as 2y? Multiply by what? 2. So I'm going to multiply this entire equation by a factor of 2. We're going to scale it up by a factor of 2. So the y's are going to be the same. Multiply by 2. Well, 2 times 6x is 12x. 2 times -y is -2y. And 2 times 4z is going to be plus 8z is equal to 2 times -3 is -6. Any questions on how we got this here? Are we good with this here? Yes? Okay. I'm going to erase this here because I don't have room to leave it. And what we're going to do is we're going to place this equation, or y'all can rewrite it underneath that equation there, because we're going to eliminate it out. So what we want is that the 2y and -2y combine together to give me what number? 0. Yes, we want it gone. We want it eliminated. Would we add them or subtract them? We have -2, or 2 plus -2, or 2 minus -2? So 2 minus -2, well, the negative and negative would make a, and 2 plus 2 is that what we wanted? No, so we would add them. And the way I try to keep it straight is if the signs are opposite, we add. If the signs are the same, we subtract. Now, the other real catch to it, and again, I did this last hour, is if we have the wrong sign, and we go through and make sure we're actually doing the addition or subtraction, not just saying, okay, we eliminated y, marked it out because that's what we said we're eliminating, but actually do it, it'll tell us like we just did there. 2 minus -2, okay, it came out to be 4. So we don't minus, we add. Easy little fix, and we're good to go. So we look at the rest of it. 4 plus 12 is 16. Let's keep it in blue. So we have 16x. 2 plus negative 2, or 2 minus 2 is 0, just like we wanted. And 3 plus 8 is plus 11z. Equals 6, or 12 plus negative 6, or 12 minus 6 is. So we've taken two equations with three variables, and now we have one equation with two. We just need another. So what we just did, we're going to do again for the other equation. But this time, our eliminator equation, what are we going to multiply everything by? 3, so that the values in front of y are going to be the same. Distribute the 3. 3 times 6x is? Minus. And 3 times 4z is going to be plus. Equals negative 9. So we're going to distribute through with that 3. Any questions on how we got this equation here? Are we good with this here? Yes. Okay. I'm going to move it up here. Let's move it up high for starters, because this is going away. I move this down just a little bit. Now, would we add or subtract these? So we're wanting the y's to eliminate, yes? So negative 3 plus negative 3 would be, well, I mean, it'd be the same as negative 3 minus 3, which would be negative 6. And we can always plug these in. If you have trouble or difficulty with a negative, type them into the calculator, negative 3 plus negative 3. If it gives you 0, we have it right, but here it's going to be subtraction. And I put it all the way through just to remind myself I'm doing subtraction on each and every single one. 2x minus 18x is going to be negative 16x. I just wanted it in blue. Negative 3 minus negative 3, well, a negative and negative make a positive, so negative 3 plus 3, or 3 minus 3 is 0, so this would be 0. And 5 minus 12 is going to be negative z equals, here a negative and negative make a positive, so negative 7 plus 9, or 9 minus 7 is almost 9 minus 7, 2. It's very easy to slip those two together because last hour I about said 17 for z. It's very easy to do. So, okay, so we did step 1, 2, and 3 because we've taken 3 equations with 3 variables down to 2 equations with 2 variables. So we've gotten 1 variable completely gone. So far, have any of the steps that we've done been over the top complicated? No. Like I said at the beginning, a lot of what we do in Algebra 2 is going to be a lot of little easy steps, but it's just keeping all these steps the same, making sure we do the same thing. Which moves us on to step 4. Repeat steps 1 and 3. Okay, I want to pick a variable to eliminate. Yes? No, that's actually kind of nice. And that kind of also answers what variable we want to eliminate. What do we want to eliminate? x, because it's already 16 and 16. If the number's already the same, let's use it, because that's going to help us out. So we can just go on and do 16x plus 11z is equal to 6, and negative 16x minus 7z is equal to 2. So are we going to want to add or subtract? Or I'm going to pause for a second. Let y'all get that written down. So what do we think? Add or subtract? Add, because 16 plus negative 16, or 16 minus 16 is 0. So we would add these all the way across. And it is indeed true that 16 minus 16 will cancel out and give us 0. 11 plus negative 7, or 11 minus 7 is 4z is equal to yes. Since I don't only have one variable, let's divide both sides by 4 and solve. So z is equal to 2. Now you've been wondering probably at this point, since I wrote it down, solve backwards seems like an odd way to say it for solving. But we got all the way down here, yes? And z is equal to 2. Well, I can't go back to the original equation because the original equations had how many variables? 3, and we can only solve for how many at most? So we'd still be solving for 2 at this point, yes? So let's go backwards up the page. Well, here I have 2 equations with 2 variables. So if I go backwards just a little bit, I can solve for one of these here, yes? Which one do we want to solve for? Doesn't matter which. I'll just have to pick one. (16x plus 11z equals 6) or negative 16x minus 7z equals 2. Allie, which one do you want to pick? The first one. So I'm going to erase this here so we can still see it. But I'm just going to take this equation and replace z with what? 2. So it's going to be 16x plus 11 times 2 is equal to 6. Well, 11 times 2 is? 22 is equal to 6. What do we do next? We'll subtract 22 from both sides because we're trying to get the value of x by itself. Just 22 minus 22 is 0, which tells us 16x is equal to negative 16. 6 minus 22 would be negative 16. And if you have to type that in a calculator, do that. And last but not least, we would divide by 16, which tells us x is equal to negative 1. Okay, let's keep going backwards up the page. Well, now I'm back at the top, yes? Well, 3 variables, and we have how many of them? So the only thing we have left is one of them, yes? So now we just need to pick one of these 3 equations to solve for the last variable y. Anybody have a choice? Colton, pick one for me. First one. So we'll pick this one here. So we say 4 times, well, x is negative 1 plus 2y plus 3 times 2 is equal to 12. And we just need to solve for the value of y. Well, 4 times negative 1 is negative 4. 3 times 2 is 6. Is equal to 12. We can combine like terms because negative 4 and 6 are both on the same side of the equal sign. And 6 minus 4 is, and it'd be positive, so we'd say plus 2. And then we would subtract 2 from both sides, which will tell me that 2y is equal to 10. Just here. And last but not least, we would divide both sides by 2, which tells us y is equal to, and that's it. So the solution for this here would be negative 1, 5, 2. So it'd be this ordered pair. This XYZ ordered pair would be the point that all three solution, or all three equations is true. Where if we graphed it out, where all three equations, or all three planes, would intersect at this point. Because these here, X, Y, Z, as in a normal ordered pair, it's X, Y, Z is going to be third. They normally try to keep these in order. So if you're not sure on the order, you can always, I mean, X, Y, Z is always going to be X, Y, Z. Some of them, they might give you W, S, T, or some other letters. They're going to be in alphabetical order, first to last. Or you can just put them above it if you just want to make sure that I know which ones you're talking about. Any questions on this here before we look at the next one? So let's look at this one here. This one here, it might be easier to pick the eliminator equation before the variable. First one, because it's all ones, isn't it? X, Y, and Z are all one. Okay, let's use it. So we can go on to note it, eliminator equation. That's the one we're going to use. We're going to use the top one. Well, what variable do we want to eliminate? X, Y, or Z? Anybody have a preference? Because I know which one I'd pick, but what do you guys want to do? What do you say, Brian? Why? Well, oh hey, the first and third equation both have 1 in it. Let's do that. Because when we write it down, I'll say 5x plus 5y plus 5z is equal to 3, and the other one's going to be 4x plus y minus 3z equals negative 6. Well, since we're eliminating y, the y's, as we said, are already the same, yes? So I don't have to change the eliminator equation at all for us to be able to eliminate y out of this equation. So we can go on and throw it right underneath because the values in front of y are already the same. That's kind of nice. Would we need to add or subtract these? Yeah, subtract, because the signs are the same. Because y minus y would give us 0. 4x minus x would be 3x. 4 minus 1 would be 3. 1 minus 1 is 0. And negative 3z minus 1z, or negative 3 minus 1 is 4z. And negative 6 minus 2 is going to be negative 8. And again, if you're not sure on these, especially with negatives and all these different signs, type it in. Type it in a calculator. It will deal with it for us. Okay. Well, the other equation over here, we don't have 1y, we have 5. So we're going to have to scale our eliminator equation. So we want to turn 1y into 5y. So what do I need to multiply our equation by? 5. We need to multiply both sides by 5 to get them to be the same. Well, 5 times x is going to be 5x plus 5 times y is, and 5 times z is plus 5z, and 5 times 2 is 10. Are we good with how we got this equation here? Yes? I'm going to move it over there. Five y and 5y, will we add or subtract? We would subtract because the signs are the same. 5x minus 5x. 5y minus 5y. 5z minus 5z. So everything's zeroed out on that side, so the whole side is 0. 3 minus 10. Will 0 ever equal negative 7? No, so this here is a false statement, yes? So that means that this is no solution. Because that means that those two planes there are parallel to each other. They will never cross. And since they will never cross, this here is a no solution. It doesn't work. Any questions on this here? All right. I know we're pushing time a little bit, but we'll see here if we can get through this. If not, we'll finish it tomorrow. Well, which equation do we want to be the eliminator equation? First one. What variable do we want to eliminate? We can do y, but there might be one easier. Because what is z for all three? 1. That's even easier. Because we can say x minus y minus z equals negative 3 is one of them, 5x minus 5y plus z equals negative 15 is the other. Well, since z is already the same in all three, it's already 1, I don't have to change a thing. We can go on and throw them in. Now, looking at this first equation here on the left, would we add or subtract? Add. because the signs of z are opposite. So we need to add these. Now, x plus x is negative y plus negative y is negative 2y. Negative z plus z, negative 1 plus 1 is 0. 1 minus 1 is 0. And negative 3 plus negative 3 is going to be negative 6. Any questions on this so far? Well, if we look at the other one, the signs of z are the same, so we would subtract. When the signs are the same, we subtract. 5x minus x is 4x. Yep. 5y minus negative y, negative and negative make a positive. So this here would be plus, not plus, minus 4y. And z plus negative z is 0. Negative, negative make a positive. So negative 15 plus 3 would be negative 12. Now, when we look at these here for our next one, we always want to go bigger, not smaller. It's easier to scale things up than it is to scale things down. So we look at this here. So 4x minus 4y equals 12. I'm going to leave that equation alone. Now, I'm just going to go on and pick for us. We're going to eliminate x first. So what do I need to multiply 2x minus 2y equals negative 6 by to give us 4x? 2, yes? Some of y'all might see what's going to happen here. Well, 2x times 2x is 4x. 2 times negative 2y is going to be negative 4y equals negative 12. Would we add these or subtract these? Subtract because the signs are the same. 4x minus 4x is 0, like we wanted. Negative 4y minus negative 4y. Well, the negative and negative make a positive. Negative 4 plus 4 is 0. Oh, well, that's not looking good. That's like what we had before, isn't it? Let's look at the last one. Negative 12 minus negative 12. Well, negative, negative make a positive. Negative 12 plus 12, or 12 minus 12 is 0. Is 0 equal to 0? Is that always true? Well, yeah, 0 will always equal 0. So that means we have infinitely, many infinitely many solutions. Infinitely many solutions. Because if we get all the way down to the bottom and it's 0 equals 0, it works. Now, if on one of the previous steps you get 0 equals 0, you still need to make sure the other equation, the other elimination step, does not give you a false statement. 0 equals negative 7 or 0 equals 7 like we had on the previous one, because it means those two don't intersect. Because if we get 0 equals 0, we need to make sure we at least have an equation on the other one if we got it in the second step, because then they cross. If I get 0 equals 0 and 0 equals negative 7, then it's still no solution. because if I ever get 0 equals a number, it does not work. Y'all have a good rest of your day. We'll see you tomorrow.